Polymagnetism. A compass needle points towards the magnetic north pole because it aligns with Earth's magnetic field. Tiny particles of iron-bearing magnetic minerals are found in basaltic magma. These minerals act like miniature compass needles as they cool to form new seafloor. Their magnetic field aligns with Earth's magnetic field. Thus, the orientation of Earth's magnetic field at the particular time becomes frozen in the rock as it solidifies. Any later change in the strength or direction of Earth's magnetic field will not significantly change the characteristics of the field trapped within the solid rock. The fossil or remnant magnetic field of a rock is known as polymagnetism. A magnetometer measures an amount and direction of residual magnetism in a rock sample. In the late 1950s, geophysics taught sensitive magnetometers just above the ocean floor to detect the weak magnetism present in the rocks. When plotted on charts, the data revealed a pattern of symmetrical magnetic strips or bands on both sides of a spreading center. The magnetized minerals contained in the rocks of some strips owed to Earth's present magnetic orientation to enhance the strength of the local magnetic field, but the magnetism in rocks in adjacent strips weakens. In 1963, geologists Drummond Matthews and Frederick Vine and Lawrence Morley proposed a clever interpretation. They knew that Earth's magnetic field reverses at irregular intervals of a few 100,000 years. In a time of reversal, a compass needle would prevent south instead of north, and any particular magnetic material of fresh seawater, fresh seafloor basalt at a spreading center would be imprinted with a reversed field. The alternating magnetic strips represent rocks with alternating magnetic polarity, one band having normal polarity magnetized in the same direction as rock magnetic field direction, the next band having reversed polarity. Opposite from today's direction. These researchers realized that the pattern of alternating weak and strong magnetic field was symmetrical because freshly magnetized rocks born at the ridge are spread apart and carried away from the ridge by plate movement. Similar magnetic patterns have been found on land and independently dated by the other means. By 1974, scientists had compiled charts showing the paleomagnetic orientation and the age of the seafloors of the Eastern Pacific and Atlantic for about the last 200 million years. Plate tectonics beautifully explains these patterns, and the patterns themselves are among the most compelling of all arguments for the theory. Polymagnetic data have recently been used to measure spreading rates to calibrate the geological timescale and to reconstruct continents. Polymagnetism has been among the most productive specialists in geology for the past 3 decades, and other lines of polymagnetic investigations have also shed light on the process of plate tectonics. Apparent polar wandering. Geologists already know the periodic magnetic field reversal are not the only unusual feature of Earth's magnetic field. The plot of the apparent position of the north magnetic poles as measured by the magnetic orientation of rocks in North America, South America, Europe, and orientation of rocks in North America, South America, Europe, Africa, showed that the magnetic pole seems to have moved. It appeared to have migrated to its present position from much further south from a point in the Pacific Ocean. So, because the actual pole wandering was a very remote scientific possibility, and having more than one north magnetic pole at the same would be impossible, the pattern strongly suggested the poles probably stayed put and the continents might have moved in relation to the pole and to one another. Geophysicists examined this possibility. If these continents had once been united and had drifted over Earth's surface together, they should have identical path of apparent polar wandering terminating in coincidence at the North Pole's present position. Armed with this information, geologists quickly noticed a fault through Scotland's Caledonian Mountains, joined with the Cabot Fault, extending from Newfoundland to Boston. This and other evidence strongly suggested that the continents have indeed drifted apart, carrying their magnetized rocks with them. Thank you.